Hello friends. We have come a long way. In the first three videos we have worked with this function e to the x times sine x, and we have investigated its first derivative, its second derivative, the critical points, the second degree critical points. Then we plotted all those things, all those information in the number line, and finally we computed the maxima and minima. We definitely had these small signs here, and we figured out that this number line for f prime x and f double prime x can be a very handy tool for reading off information to draw the final graph. For example, we can talk about the interval of increase, or the where the function is increasing. That's the place where you would have the first derivative positive, right? So let's look at the number line of first derivative. We see that this, this, and this. Let me zoom a little bit. In these three intervals, from negative 2 pi to negative 5 pi by 4, and then from negative pi by 4 to 3 pi by 4, and then from 7 pi by 4 to 2 pi by 2 pi. In these three intervals, we have first derivative as positive. So we will use this information and we will write this down in this slot. By the way, if you have not downloaded the template, you can do that from the link in the description. And also, if you have not watched the previous videos and if you're wondering how we got up to here, you can watch the previous videos of this series. This is the fourth one. Okay, so that's the interval of increase, and the interval of decrease would be exactly where the first derivative is negative. So that's negative 5 pi by 4 to negative pi by 4 union 3 pi by 4 to 7 pi by 4. Realize that I'm writing them in open intervals because at those points the first derivative is 0. So we really don't worry about those points. Next we go into the interval of convexity and concavity. Now to talk about convexity and concavity of a function, we might want to motivate a little bit, but this is not a concept video, so there is not much room to talk about that. But once upon a time, I learned it from one of my students. There is a very nice way of thinking about convexity and concavity of a curve. Uh, think of convexity as above tangent. So if your graph is like this, and if you draw a tangent at any point of the graph, you can see that your graph is above tangent. And that particular situation, it's very easy to remember in this way, is where the graph is convex. Even if it's increasing, even if the function is increasing, it would look like this. Then if you draw a tangent, still the graph is above the tangent. So concavity would be exactly the opposite. It would be below tangent situations. For example, this. There is a very nice discussion in Hilbert's Geometry and Imagination on this kind of stuff. So you can look into it, of course. The other one would be the picture would be like this. So this is the case, these two are the cases where the function is concave, below tangent. Okay. This is above tangent. Alright, now coming back to this chart, we have to find the interval of convexity, where that is where the second derivative is 0. Now you might be wondering, why would the second derivative be 0 in these situations? That is of course part of the concept lectures, which we cannot really discuss here. But convexity would mean that the second derivative is necessarily positive. So in this case, we can read it off from the number line of the second derivative, and that would be precisely negative 2 pi to negative 3 pi by 2 union negative pi by 2 to positive pi by 2 union 3 pi by 2 to 2 pi. Similarly, we will have intervals of concavity, that is where the second derivative is negative. So we can again read it off from the number line, and that would be negative 3 pi by 2 to negative pi by 2. So negative 3 pi by 2 to negative pi by 2 union pi by 2 to 3 pi by 2. So now you see what is the use of this number line, right? We have all the information very properly organized, and we can read it off from the number line, and works very nicely. All right, about the asymptotes, if you know how to compute asymptotes, you would know that this particular function does not have any vertical or horizontal asymptote.